Hello, math students. Welcome back to Module 3 called Rational Numbers, and the lesson is Lesson 11, and it's called Distance on the Coordinate Plane. Our goal for today is we will determine the distance on the coordinate plane. The question that I want you to think about in this lesson is, how do you determine distance without counting? So that's something interesting to try to figure out. Things to know. So the first thing that we're going to do, according to this lesson, is we need to plot some points on our coordinate plane. And you need to remember that this horizontal number line is called the x-axis. You need to remember that this vertical number line is called the y-axis. Okay? And remember, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, just some reviews of what the coordinate plane works with. And then we're going to go ahead and plot. So I'm going to put in some number values on here. 1, 2, 3, 4, 5, 6, 7, 8. 1, -2, -3, -4, -5, -6, -7, -8. -1, -2, -3, -4, -5, -6, -7, -8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, I didn't stop at 8 for any reason other than that's what fit on there. So this one says plot and count. So the first point that we are going to plot says 0, -3. So remember, when you see an ordered pair, I would like you to write this until we've got it down. So 0 means 0 to the right or left, 0 right, and down, because it's negative, down 3. Okay, so I'm going to go 0 to the right, 0 to the left, but I'm going to go down 3. So I'm going to go 1, 2, 3 down and put a dot. So I now know that this point is called 0, -3. Okay, so now let's do the next one. And this one says 0 again to the right or left. And then this time I'm supposed to go up 6. So again, start at 0, except don't go left or right, but go up 6. 1, 2, 3, 4, 5, 6. And that happens to be right there, so this one is called 0, 6. Okay, and now the next question that it asks us is, what is the distance? So when they're asking you that, they want to know, what is the space from this point down to this point? And so basically we have to try to figure out how far away these two are. And if you go back to our question, it says, how do you determine the distance without counting? Well, let's count it first just so that we can see what we learn. So if this point is here and this point is here, it doesn't really matter where you start. You're just going to count your hops from one point to the other. I want you to notice, however, that we are able to count because it's sitting in the exact same x coordinate position. So since the x coordinates are the same, that means we can just count straight down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the distance between these two is 9 units. Okay, and the one thing that I want to be very careful to make sure that I point out to you is you still have to count this origin value because it still counts as a hop. So let's count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 units. So we could say this point is 9 units away from this point. Okay, so the distance on this one would be 9 units. Okay, so let's try it again with another one. And this time it says plot -7, 4. So again, we're writing down what we do. So we go to the left 7 and up 4. Okay, we can do that starting at the origin. 1, 2, 3, 4, 5, 6, 7. And then up 4. Start at the origin. 1, 2, 3, 4. So I'm going to go over to here, and this point right here is called -7, 4. Okay, that's what that point is called. And then this one says that I'm supposed to go to the right 3, because it's a positive number, and up 4. Okay, so to the right 3. So start at 0. 1, 2, 3, and then up 4. So 1, 2, 3, 4. So I'm sitting about there. And that one is called to the right 3, up 4. Okay? Now, the next question that it asks right here is, what is the distance from these 2 points? So again, we've got to figure out how did we get from here to here, okay? And so if we're looking at it, again, we notice that they share a coordinate in common. This time the coordinate in common is 4. This time over here, the coordinate in common was 0. And since they have a coordinate in common, that means that we can just count from where we started to where we ended. So this is where we started, so we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I see that from here to here, the distance is, on this one, 10 units, okay? And I'm sorry if that coloring is getting confusing, but hopefully you can keep it straight. So that would be 10 units. So now I want to look at something, and I want to point out something. It says, what mathematical operation can be used to determine the distance between 2 points? Well, let's look at it and see if you are starting to see what I'm seeing, which is, let's go back and take the 2 points we started with. We had 0, -3, and the other point that we had was 0, 6, okay? And so if we're trying to figure out how we traveled from this point to this point, what we are actually doing is we're trying to find the distance between the two. Well, if you're looking at this, the distance between these two is nothing because it's the same value, right? However, if you're trying to go from -3 all the way over here to +6, and I'm pretending this is a horizontal number line so that you guys can see what we're talking about, what we're actually doing is we're trying to find the distance in between. So to find the distance in between, can't we just subtract? Well, let's try it. If we start on 6, right, and we're going backwards to figure out what we're doing. So we're taking 6 minus a -3. Well, when we do that, we're trying to get from 6 down to -3, and when you're going down, you're actually subtracting. So count how many are in between. That's 6. So this would be 5, 4, 3, 2, 1, 0, -1, -2, -3. I didn't space them very evenly at all. So let me write in the numbers because I'm sorry, I did not space them at all evenly, which I apologize. But so we're trying to get to here. So count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer to this problem right here is 9 because we started at 6, we're going back to -3, so we're subtracting it. So 6 minus a -3 actually gives us an answer of 9. Okay, so let's try it with the other one and see if it works that same way. So our 2 points were -7, 4, and 3, 4. So because we have the 4's in common, we don't have to worry about those this time. But this time, what we have is we have a -3 or a -7. So let's say -7 is here. -6, -5. Okay, I'm going to do it. -6, -5, -4, -3, -2, -1, 0, 1, 2, 3. So we're going to go that way this time, and they're actually even spaced. So this is -7. So we're trying to find the distance between these two now, okay? And it doesn't matter which way we go, but if we're starting up here on 3, we're going to say take 3. We're going down to -7. So let's try it and see what happens. We start at 3, and we're going down to -7, so count the hops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that 3 minus a -7 is 10 because it gave us 10 hops. So that's how we found the distance from those 2 points. So again, to answer this question, what mathematical operation can be used to determine the distance between 2 points? The answer to that is subtraction, because you're trying to get from one point to the other. So subtraction, why did I put an S in there? Sorry. Subtraction actually gets us from one point to the other, as long as one of the coordinates are the same. That's kind of like the most important piece about this whole lesson, is the subtraction only works if they have a coordinate that is the same in both points. Okay? So let's go back up to our goal. Today we will determine the distance on a coordinate plane, which we did. How do you determine the distance without counting? Well, the answer to that is that you can subtract them. Okay? And so that's kind of something that's leading up to our next lesson, but I'll talk about that in the next lesson. Okay? All right, kiddos, that's all I have for you today. Talk to you soon. Bye!